This problem is asking us to find all of the trigonometric ratios if we are given the tangent ratio. One way to do this is to model out the triangle and solve it, but I think it's better to use the Pythagorean identities and our relationships. So we know that if tangent of theta is 1/2, the cotangent of theta is the reciprocal of that, or 2. So now we've gotten that one taken care of. We also know that 1 plus tangent squared theta equals secant squared theta. So we can plug in the 1/2 for tangent. Since it's tangent squared, we have to square it. And that gives us 1 plus 1/4. 1 is really 4/4. 4/4 plus 1/4 is 5/4. And then what we would need to do is square root each side to get secant alone. So that gives us the square root of 5 over 2 for secant theta. So we know that secant of theta is square root of 5 over 2. And that means our cosine of theta, which is the reciprocal of secant, is going to be 2 over the square root of 5. If we rationalize that, we get 2 root 5 over 5. And now we need to figure out our sine of theta. I like to use the Pythagorean identity of cosine squared theta plus sine squared theta equals 1, where we can plug in 2 root 5 over 5 for cosine. And since it's cosine squared, we need to square that. Plus sine squared theta equals 1. If we square this, it's going to be 2 times root 5 times 2 times root 5, and 2 times 2 is 4. And root 5 times root 5 is 5. And our denominator, 5 times 5, is 25. 4 times 5 is 20 over 25. Subtract that on both sides. Remember, 1 is really 25 over 25. So 25 minus 20 is 5 over 25. We could simplify it, but since we have to square root each side to figure out what sine of theta is, it's actually better to just leave that. So we get square root of 5 over 5. Square root of 5 over 5. So that tells us that our sine of theta is square root of 5 over 5. And our cosecant of theta is the reciprocal of that, so 5 over root 5. And when we rationalize that, we get 5 root 5 over 5, but the 5's cancel, so our cosecant simplifies to just the square root of 5.